Somewhere in the Nevada desert, a dry lake bed holds the outline of a runway that appears on no official map. Its markings visible only from altitudes most aircraft never reach. The land around it stretches flat and pale beneath a sky that seems wider than anywhere else on Earth. And the silence there is said to be so complete that visitors sometimes hear their own heartbeat echoing back from the empty hills. This is a place where secrecy became its own kind of architecture, where chain-link fences and warning signs gave way to mythology, and where the truth, whatever it might be, has always moved more slowly than the rumors that surround it. If these quiet journeys help carry you toward rest, subscribing means more of them will find their way to you. The desert waits, patient and still, and the story can begin now. In the high desert of southern Nevada, approximately 83 miles to the northwest of Las Vegas, there exists a dry lake bed known as Groom Lake. It sits within a broad valley surrounded by modest mountain ranges, and from above, if one were to look down upon it from a great height, it would appear as a pale, flat expanse of cracked earth, whitish in color and roughly 4 miles in length, stretching across the valley floor like a forgotten mirror that no longer reflects anything at all. The lake bed is part of a much larger area of federally restricted land called the Nevada Test and Training Range, which itself occupies a substantial portion of the state, and Groom Lake rests near its center, quiet and unremarkable in its geography, though it has accumulated a certain fame over the decades for reasons we shall come to understand in time. The valley containing Groom Lake is sometimes called the Emigrant Valley, though this name does not appear on all maps, and in truth, the region has been known by various designations throughout its history, none of which have ever quite settled into universal acceptance. To the east rises the Groom Range, a series of rocky hills that reach modest elevations and cast long shadows in the morning light. To the south and southwest, one finds the Papoose Range, another collection of desert mountains, and beyond these ranges, more valleys and more mountains continue in a repeating pattern that characterizes this entire portion of the American West. This geological arrangement, with its alternating basins and ranges running roughly north to south, gives the region its technical name among geologists, who refer to it as the Basin and Range Province, a designation that describes the fundamental structure of the land itself. The Basin and Range Province extends across much of Nevada and into portions of Utah, Arizona, Oregon, and California, and it represents one of the more distinctive geological regions of North America. The province was formed over millions of years through a process of crustal extension, wherein the Earth's crust was stretched and pulled apart by tectonic forces, causing it to fracture along great faults. As the crust stretched, blocks of rock between these faults tilted and shifted, with some blocks rising to form mountain ranges, while others dropped to create the intervening basins. The result is a landscape of remarkable regularity when viewed from space, a corrugated pattern of parallel ridges and valleys that continues for hundreds of miles. Groom Lake sits within one of these basins, a typical example of the province's geography, and if one were to stand upon the dry lake bed and look in any direction, one would see the characteristic profile of fault block mountains rising from the valley floor. The mountains surrounding Groom Lake are not particularly tall by the standards of the Western American ranges, and they lack the dramatic granite peaks or snow-capped summits that one might associate with the Sierra Nevada or the Rocky Mountains. Instead, they are modest elevations of exposed rock and sparse vegetation, their slopes covered in the greys and browns of desert terrain, with occasional patches of juniper or Joshua tree at higher elevations. The rock itself tells a story of great antiquity, with layers of sedimentary stone laid down in ancient seas hundreds of millions of years ago, later uplifted and exposed by the faulting that created the basin and range topography. In some places, one can find limestone containing the fossilized remains of marine creatures, a reminder that this now arid land was once covered by warm, shallow water in the deep past of geological time. The dry lake bed at the center of the valley is what geologists call a playa, a Spanish word meaning beach, which has been adopted into English to describe the flat, dry floors of desert basins where water occasionally collects and then evaporates, leaving behind deposits of clay and salt. Groom Lake is typical of such playas, with a surface of fine, pale sediment that becomes slick and muddy after rain, then dries again into a remarkably flat and hard surface. The flatness of playas has made them useful for various human activities throughout history, including the landing of aircraft, and it was this natural characteristic of Groom Lake that would eventually attract the attention of those seeking a remote location for sensitive aviation projects. But this came much later, and for most of the lake bed's existence, it lay undisturbed beneath the desert sky, accumulating its layers of sediment in patient silence. During the Pleistocene epoch, which began approximately 2.5 million years ago and ended roughly 11,000 years ago, the climate of the Great Basin region was considerably wetter and cooler than it is today. This period, sometimes called the Ice Age, saw much of North America covered by great sheets of glacial ice, though the glaciers themselves did not extend into the Nevada desert. Instead, the region experienced what scientists call a pluvial climate, meaning that rainfall was more abundant and temperatures were lower, reducing evaporation and allowing water to collect in the desert basins. During these wetter periods, many of the dry lake beds that now characterize the Nevada landscape were filled with substantial bodies of water, creating a network of lakes across the region. Groom Lake held water during these times, a modest lake fed by runoff from the surrounding mountains, its shores perhaps visited by animals now extinct and by the earliest human inhabitants of the continent. The evidence of these ancient waters can still be found in the sediments beneath the playa surface, layers of clay and organic material that speak to a time when this now barren valley supported a more vibrant ecosystem. As the Pleistocene gave way to the Holocene, our current geological epoch, the climate of the Great Basin gradually warmed and dried, and the lakes began to recede. Some disappeared entirely, leaving only their flat playa floors as evidence of their former existence, while others shrank to a fraction of their previous size. The Great Salt Lake of Utah is one such remnant, a surviving portion of the much larger Lake Bonneville that once covered vast areas of the region. Groom Lake followed a similar pattern, its waters evaporating as rainfall decreased and temperatures rose. until eventually, the lake dried completely, leaving behind only the pale, cracked surface that exists today. This process of drying occurred over thousands of years, a gradual transformation that no single generation of living creatures would have noticed. And by the time modern humans arrived in the region, the lake had long since become a memory preserved only in the geological record. For thousands of years after the end of the Pleistocene, the dry lakebed and its surrounding valley remained in a state of quiet solitude, visited occasionally by the indigenous peoples who moved through the desert in search of food and water, but never permanently settled due to its harsh conditions and lack of reliable water sources. The native peoples of the region, including those later known to European Americans as the Southern Paiute and Western Shoshone, knew the desert intimately and traveled its valleys and mountain passes according to seasonal patterns. But the immediate vicinity of Groom Lake offered little to attract extended habitation. It was simply one valley among many, unremarkable in its resources, distinguished primarily by its remoteness and the severity of its climate. European and American exploration of the region came relatively late, as the interior deserts of Nevada were among the last areas of the continental United States to be mapped and surveyed. The name Nevada itself comes from the Spanish word meaning snow-covered, a reference to the Sierra Nevada mountain range on the state's western border, and the interior deserts seem to offer little of interest to the settlers who passed through on their way to California during the gold rush of the mid-19th century. The Emigrant Valley, through which Groom Lake stretches, may have received its name from the trails used by some of these westward travelers, though the precise origin of the name has become obscured by time. For many decades, the valley remained essentially empty, known only to the occasional prospector searching for mineral wealth in the surrounding mountains, or to the ranchers who grazed cattle on the sparse vegetation of the lower slopes. The modern history of the area began to take shape during the Second World War, when the United States military was rapidly expanding its training facilities across the desert regions of the American Southwest. The clear skies, minimal rainfall, and vast empty spaces of Nevada made it ideal for aerial training exercises, and numerous bases and bombing ranges were established throughout the state during the 1940s. The area that would eventually contain Groom Lake became part of a larger complex used for aerial gunnery practice, where pilots could train in bombing and strafing techniques without endangering civilian populations. The war ended in 1945, but the military retained its presence in the Nevada desert, and the ranges continued to be used for various training purposes throughout the late 1940s and into the 1950s. During this same period, another significant development was taking place nearby, following the end of the Second World War and the beginning of the Cold War with the Soviet Union. The United States embarked upon an intensive program of nuclear weapons development and testing. A suitable location was needed for conducting these tests, and after considerable evaluation, a site in southern Nevada was selected. This location, which became known as the Nevada Test Site, was established in 1951, and over the following decades, it would become the primary venue for American nuclear weapons testing. The site was located adjacent to the Nevada Test and Training Range, and the first nuclear detonation at the location occurred on January 27, 1951. Many more would follow over the subsequent years, until atmospheric testing was banned by treaty in 1963, after which underground testing continued until 1992. The proximity of the Nevada test site to Groom Lake is significant for understanding how the area came to be designated in the manner that it was. The Atomic Energy Commission, which oversaw nuclear weapons development during this period, divided the surrounding region into numbered areas for administrative purposes, creating a grid of sections that could be referenced on maps and in official documents. Each area received a simple numerical designation, and the section containing Groom Lake was labeled as Area 51. There was nothing particularly special or sinister about this designation. It was simply the next number in the sequence, assigned in the same bureaucratic manner as Area 15, Area 27, or any other portion of the map. The number 51 did not indicate any secret significance, nor was it chosen to obscure the nature of activities conducted there. It was merely a label, applied to one portion of a larger administrative grid, and if circumstances had been slightly different, the location might just as easily have been numbered as Area 47 or Area 58, and none of its subsequent mystique would have attached to those alternative designations. The Nevada desert at night, particularly at the elevation of Groom Lake, which sits at approximately 4,462 feet above sea level, possesses a particular quality of silence and clarity that is difficult to find elsewhere. The air is thin and dry, with little moisture to absorb or scatter the light from distant stars, and on clear nights, which are frequent in this region, the sky reveals itself with remarkable depth and brilliance. The Milky Way stretches overhead in a great luminous band, and stars that would be invisible from more humid or light-polluted locations emerge in their thousands, filling the darkness with points of steady light. The silence, too, is notable, for there is little vegetation to rustle in the wind, few insects to chirp or hum, and no bodies of water to lap against their shores. The dry lake bed reflects no sound, and the surrounding mountains absorb what noise might travel from distant roads or settlements. Standing in such a place at night, one might hear only the slight whisper of wind across the playa surface, or the occasional call of a nocturnal bird, or nothing at all except the soft pressure of silence against the ears. This quality of emptiness, of vast and undisturbed space beneath an infinite sky, characterized the Groom Lake area before humans arrived with their measuring instruments and their construction equipment and their carefully guarded secrets. The valley had existed in this condition for thousands of years, accumulating its sediments, receiving its occasional rains, witnessing the passage of seasons and the slow rotation of stars overhead, and asking nothing of the world beyond its mountain borders. It was a place of geological patience, of slow time measured in the accumulation of dust and the weathering of rock, and whatever purposes humans would eventually find for it. The land itself remained indifferent, continuing its ancient processes of erosion and deposition without reference to the activities taking place upon its surface. The dry lake waited, as it had always waited, beneath the clear desert sky, and the stars turned overhead in their nightly procession. and the silence of the high desert settled across the valley floor like a blanket laid gently down by careful hands. In the spring of 1955, as the desert began to warm and the last of the winter rains had long since evaporated from the cracked earth of the Great Basin, a small aircraft carrying two men of considerable purpose made its way across the vast and empty stretches of southern Nevada. The men aboard were Richard Bissell, a CIA officer whose quiet demeanor belied the scope of his ambitions for American intelligence gathering, and Kelly Johnson, a Lockheed engineer whose reputation for designing remarkable aircraft had already placed him among the most accomplished minds in American aviation. They were not flying for pleasure, though the landscape beneath them possessed a stark and austere beauty that might have captured the attention of anyone inclined toward such appreciation. Rather, they were engaged in a methodical search, scanning the terrain below for a place that most people would never wish to find, a location so remote and so forbidding that it might serve as the perfect cradle for one of the most sensitive aircraft development programs the United States had ever undertaken. The need for such a place had become pressing in those years. As the Cold War settled into its long and anxious rhythm, and as American military planners recognized that understanding Soviet capabilities required eyes that could see far beyond the borders that diplomacy could not cross. The aircraft they intended to build and test was unlike anything that had flown before. A machine designed to soar so high above the earth that it would float in that thin and lonely region where the sky begins to darken toward the black of space, where the curvature of the planet becomes visible to the unaided eye, and where, most importantly for the purposes of intelligence gathering, no Soviet fighter or missile could reach. But such an aircraft, precisely because it was so unusual and so far beyond the ordinary experience of aviation, could not be developed in the open. It could not be tested at existing military airfields where curious eyes might observe its strange silhouette, where its extraordinary climbing ability might prompt questions that could not be safely answered. And so Bissell and Johnson flew on, searching for a hidden corner of the already hidden American desert, a place where secrets could be kept simply because no one would think to look there. As their aircraft passed over the dry lake beds and mountain ranges that characterize so much of Nevada, their attention was drawn to a particular formation, a pale expanse of dried mud and mineral deposits that stretched flat and smooth for miles beneath them. This was Groom Lake, and at first glance it appeared to be little more than another of the countless players that dot the basin and range country of the American Southwest. These lake beds, remnants of the vast inland seas that covered this region thousands of years ago during wetter climatic periods, are common enough that most maps do not bother to name them all. But to Bissell and Johnson, whose eyes were trained to see potential rather than mere geography, Groom Lake possessed qualities that set it apart from its unremarkable neighbors. The surface was extraordinarily flat, hard-packed from centuries of mineral deposition, and long enough to serve as a natural runway for even the most demanding aircraft. The mountains that surrounded it on all sides created a natural bowl that would shield activities from distant observation. And perhaps most importantly, this particular stretch of desert already fell within the boundaries of the Nevada test site. The sprawling federal reservation where atomic weapons were being tested with regularity, which meant that the airspace above was already restricted and that the presence of military security personnel in the region would not attract undue attention. The two men recognized almost immediately that they had found what they were looking for, and upon landing and making a more thorough inspection of the site on foot, their initial impressions were confirmed. The lake bed was suitable for aircraft operations. The surrounding terrain provided natural concealment, and the existing security infrastructure of the atomic testing program could be extended to encompass this new facility without drawing the kind of notice that establishing an entirely new restricted zone might provoke. Within weeks, their recommendation had made its way through the channels of government bureaucracy and landed upon the desk of President Dwight Eisenhower, who understood perhaps better than most the delicate balance between the need for intelligence and the risks of provocation in an age of nuclear weapons. By July of 1955, Eisenhower had given his approval, and the process of transforming this desolate lakebed into a functional, if austere, test facility began in earnest. The aircraft that would first take to the skies above Groom Lake was designated the U-2, a name chosen precisely for its blandness, its suggestion of mundane utility rather than extraordinary capability. In truth, the U-2 was anything but ordinary. Kelly Johnson and his team at Lockheed's Advanced Development Projects Division, known informally as the Skunk Works for reasons related to its proximity to an unpleasant-smelling plastics factory, had designed an aircraft that sacrificed almost everything in pursuit of a single goal, which was altitude. The U-2 was constructed to fly at approximately 70,000 feet above the Earth, an altitude so extreme that it existed beyond the operational ceiling of any other aircraft in the world at that time. To achieve this remarkable height, the U-2 was built with wings of exceptional length, spanning more than 80 feet from tip to tip, which gave the aircraft a glider-like appearance and allowed it to generate lift in the thin air of the upper atmosphere, where conventional wings would be useless. The fuselage was stripped of everything non-essential. The landing gear, designed to drop away after takeoff in some early configurations to save weight, and the pilot required to wear a pressure suit similar to those being developed for astronauts, because at 70,000 feet, the air pressure is so low that human blood would boil without protection. The construction of the test facility proceeded quickly, driven by the urgency of Cold War intelligence needs and facilitated by the remote location that made large-scale operations possible without interference. Temporary buildings were erected. A runway was marked out on the hard surface of the lakebed. Fuel and supplies were trucked in along dusty roads that connected the site to the broader network of military infrastructure in Nevada. By August of 1955, the facility was ready for its first flight tests, and a pilot named Tony Levier, who had already established himself as one of the most skilled test pilots in Lockheed's employ, was given the honor of being the first to land an aircraft on the strange and isolated runway at Groom Lake. Levier's arrival marked the true beginning of operations at the site, the moment when this empty stretch of desert ceased to be merely a promising location and became instead an active participant in the secret technological competition of the Cold War. The flights that followed in the months and years after Levier's initial landing were remarkable, not only for what they achieved, but also for the unexpected consequences they produced. When the U-2 climbed to its operating altitude of 70,000 feet, It entered a region of the atmosphere that commercial aircraft of that era could not approach. The airliners of the 1950s typically cruised at altitudes between 25 and 35,000 feet, and even military fighters rarely exceeded 45 or 50,000 feet in normal operations. This meant that pilots and passengers aboard conventional aircraft had no frame of reference for objects operating at the U-2's altitude. No reason to expect that anything made by human hands might be traveling so far above them. The visual characteristics of the U-2 at altitude created effects that seemed, to observers on the ground and in lower flying aircraft, to defy explanation. At 70,000 feet, the U-2 was operating in the upper reaches of the stratosphere, where the atmosphere is so thin that the sky above appears not blue, but a deep and darkening shade that approaches the blackness of space. More significantly for what was to follow, an aircraft at this altitude remains in direct sunlight long after the sun has set for observers on the ground or at lower altitudes. In the evening hours, when the Earth below has rotated into shadow and the sky appears dark to those standing on its surface, an aircraft at 70,000 feet continues to catch the rays of the setting sun, its metal surfaces reflecting light in ways that can seem startling and inexplicable to anyone who observes them from below. The silver skin of the U-2, too, catching this high-altitude sunlight against what appeared to be a darkening or fully dark sky, produced a phenomenon that witnesses described in terms that reflected their confusion and wonder. Commercial airline pilots flying their regular routes across the American Southwest began reporting unusual sightings, objects that seemed to glow with their own light, that appeared far above their own aircraft, that moved in ways they could not reconcile with their understanding of aviation. Passengers looking out their windows saw things they could not explain, bright points or elongated shapes that caught the light and seemed to hover or drift in regions of the sky where nothing should have been. Ground observers, too, reported seeing strange lights in the evening and early morning hours, fiery or silvery objects that appeared and disappeared as the U-2 moved in and out of the angles that allowed its reflection to be visible. These reports began to accumulate, passed from witnesses to local authorities, from local authorities to regional offices, and eventually to the Air Force personnel tasked with investigating such phenomena. The Air Force had established a program for the investigation of unidentified flying objects several years before the U-2 began its flights, and by the mid-1950s, this program had evolved through several iterations before settling into the form known as Project Blue Book. The personnel assigned to Blue Book received reports from across the country, from military pilots and civilian witnesses alike, and their task was to evaluate these reports and determine, where possible, ordinary explanations for what had been observed. In most cases, the explanations were straightforward, involving misidentified aircraft, weather balloons, astronomical phenomena, or the various optical effects that the atmosphere can produce under certain conditions. But the reports that began arriving from the American Southwest in the months after the U-2 became operational presented Blue Book investigators with an unusual challenge. The investigators understood, because they had been briefed on the U-2 program, that many of the sightings they were receiving corresponded precisely with the times and locations of U-2 test flights. They could see in their records that a witness who reported a glowing object at a particular time and place had been looking at the sky at exactly the moment when a U-2 was passing overhead at 70,000 feet, its wings catching the last light of the sun. But this knowledge, useful as it was for understanding what had actually occurred, could not be shared with the witnesses or with the public. The existence of the U-2, its capabilities, Ts, and certainly the location of its test facility were among the most closely guarded secrets in the American government, and revealing the truth about these sightings would have compromised one of the most important intelligence assets of the Cold War. And so, the Blue Book investigators found themselves in the peculiar position of using their classified knowledge to explain away sightings without ever revealing the true explanation. They would attribute reports to ice crystals in the upper atmosphere, to reflections of high-altitude dust particles, to temperature inversions that could make distant lights appear to be close at hand, to any number of meteorological and optical phenomena that were plausible enough to satisfy most inquiries without approaching the truth. The irony of this situation was not lost on those who understood it, for in their efforts to protect the secret of the U-2, they were inadvertently contributing to the growth of public interest in UFOs, allowing the mystery to persist and deepen because the real answer could not be spoken. The U-2 would go on to play a significant role in Cold War intelligence gathering, flying missions over the Soviet Union and other nations, photographing military installations and missile sites from its untouchable altitude until the day in 1960 when one of the aircraft was finally brought down over Soviet territory, an event that created an international incident and brought the program into the harsh light of public knowledge. But by that time, the facility at Groom Lake had already proven its value, had already demonstrated that in the empty heart of the Nevada desert, it was possible to develop and test aircraft so advanced, so unusual in their appearance and capabilities, that even careful observers could not recognize them for what they were. The precedent had been established, and the site would continue to serve this purpose for decades to come, a place where the boundary between the known and the unknown was carefully maintained, where the secrets of American aerospace technology could unfold in peace, far from eyes that might watch too closely or understand too well. And so we arrive at a quieter sort of beginning, one that took shape in the late months of 1959, when the desert facility we have been describing received word that something rather extraordinary was coming its way. The U-2, for all its remarkable capabilities, was beginning to show its limitations as Soviet radar technology improved and the threat of interception grew more pressing with each passing season. Intelligence officials understood that altitude alone would no longer guarantee safety, and so the question became not how high an aircraft might fly, but rather how fast it might travel, whether speed itself could become a form of protection, a way of simply outrunning whatever dangers might rise up to meet it. The answer to this question would emerge from the same small engineering team in Burbank, California, that had created the U-2. The group that worked in a modest cluster of buildings surrounded by a wooden fence, which had come to be known by the rather informal name of Skunk Works. At the head of this team stood Clarence Leonard Johnson, though nearly everyone called him Kelly, a man whose approach to aircraft design favored elegant simplicity over complicated systems, and who possessed an unusual talent for solving problems that other engineers considered impossible. When the Central Intelligence Agency approached him about creating a successor to the U-2, an aircraft capable of cruising at speeds exceeding 3 times the speed of sound while flying at altitudes above 80,000 feet, Kelly Johnson did not dismiss the request as unreasonable, but instead set about determining exactly what such a machine would require and how one might go about constructing it from materials that could withstand conditions no piloted aircraft had ever been designed to endure. The program that resulted from these early conversations carried the designation Oxcart cart, a name chosen with the same deliberate mundanity that had characterized previous secret projects, the sort of word that would attract no particular attention if overheard or glimpsed in a filing system. The aircraft itself would eventually be called the A-12, a slender and purposeful shape quite unlike anything that had flown before, with its long fuselage tapering to a point at the nose and its twin engines mounted partway along wings that swept back at a severe angle. Looking at the design sketches, one might notice how the entire form seemed to lean forward, as though perpetually straining towards some distant destination. Every curve and angle calculated to reduce drag and manage the tremendous forces that would act upon the structure at high Mach numbers. The central difficulty, the one that occupied Kelly Johnson's engineers for months that stretched into years, concerned the simple matter of heat. When an aircraft travels through the atmosphere at 3 times the speed of sound, the air itself becomes an adversary, compressing against the leading surfaces and generating friction of such intensity that conventional materials cannot survive. At Mach 3.2, the speed the A-12 was designed to achieve, the temperatures along the forward edges of the wings and fuselage would reach approximately 1,050 degrees Fahrenheit, a figure that falls well within the range where aluminium loses much of its structural strength and begins to behave in ways that aircraft designers find quite troubling. The solution, Johnson and his team determined, lay in titanium, a metal that retained its integrity at elevated temperatures and possessed the additional advantage of being considerably lighter than steel, though working with it presented challenges that no aircraft manufacturer had ever confronted at such scale. Titanium in 1959 was not a material that lent itself to easy fabrication. The metal proved brittle and temperamental, cracking when machined with certain tools, refusing to hold its shape when welded by conventional methods, and reacting poorly to seemingly innocuous substances that caused no trouble with other metals. The engineers at Skunk Works discovered through painstaking trial that ordinary tap water, when used as a coolant during drilling operations, would cause titanium to become brittle and fail, the chlorine in municipal water supplies interacting with the metal in ways that weakened its crystalline structure. They found that cadmium-plated tools left traces on titanium surfaces that later caused corrosion, and that even the marks made by certain types of pens could initiate stress fractures during subsequent heat cycles. Each of these discoveries required adjustments to manufacturing processes, the development of new techniques, the training of workers in methods that had never been attempted before. Acquiring sufficient quantities of titanium presented difficulties of another sort entirely, ones that carried a certain quiet irony that would not become publicly known for many years. The United States, in the early 1960s, did not possess adequate domestic supplies of titanium ore, and the global market for the metal was limited, with the most significant deposits and processing facilities located in the Soviet Union itself. The Central Intelligence Agency, finding itself in need of large quantities of a strategic material produced primarily by its principal adversary, established a network of shell companies and third-party purchasers to acquire titanium on the open market, taking care to obscure the ultimate destination and purpose of these procurements. Through this arrangement, titanium mined and processed in the Soviet Union made its way through various intermediaries to the Skunk Works facility in Burbank, where it was shaped into an aircraft designed specifically to conduct reconnaissance missions over Soviet territory. The metal that had originated in one country was transformed into a machine built to photograph that same country from the edge of space, a circumstance that carried no particular moral weight but possessed a certain symmetrical quality that historians would later find noteworthy. As construction of the first A-12 airframes progressed, the remote facility in Nevada prepared to receive them. The existing infrastructure, already expanded to support U-2 operations, required further enlargement, with new hangars constructed to house aircraft somewhat larger than their predecessors, and additional support facilities built to accommodate the specialized equipment and personnel that such an advanced program would demand. The runway, already lengthy, was extended and reinforced to handle the greater weights and higher speeds involved in A-12 operations. Fuel storage expanded considerably, as the A-12 consumed specially formulated JP-7, a fuel designed to remain stable at the extreme temperatures the aircraft would encounter, with a flash point so high that one could reportedly extinguish a match by dropping it into a container of the liquid, though there seems little reason anyone would wish to verify this personally. The first A-12 arrived at the Nevada facility in February 1962, transported overland in sections and reassembled within the secure confines of the base. Testing proceeded methodically through the following weeks, with ground runs and taxi tests conducted to verify systems before anyone would attempt actual flight. The pilot selected for this distinction was Louis Walter Schock, an experienced test pilot who had joined Lockheed after flying with the Air Force, and who approached the assignment with the careful professionalism that such work demanded. On the morning of the 26th of April, 1962, Schock climbed into the cockpit of the first A-12, designated Article 121, and prepared to conduct what was intended as a high-speed taxi test rather than an actual first flight. What occurred next was not precisely what anyone had planned. As the aircraft accelerated down the runway, Schock encountered lateral oscillations in the landing gear, a wallowing motion that grew concerning as speed increased. Faced with the choice between attempting to stop and risk losing control, or lifting off and dealing with the situation in the air, he chose the latter, raising the gear and flying for approximately 2 miles at an altitude of perhaps 50 feet before setting the aircraft back down on the dry lake bed that lay beyond the runway. The landing gear had not fully retracted, and upon touchdown, one of the fillets beneath the wing separated and was left behind on the desert surface. A minor mishap in the context of experimental aviation. The aircraft itself was undamaged in any significant way, and after a brief examination, the decision was made to fly it again before day's end. though not before Kelly Johnson himself arrived to oversee the proceedings. The official first flight took place later that same afternoon, with Schalk again at the controls, this time conducting a proper departure and remaining airborne for some 40 minutes before returning to land without incident. The A-12 handled well, responding to control inputs in ways that matched the engineers' predictions, and the long process of flight testing began in earnest. Over the following months and years, additional aircraft joined the program, and the performance envelope expanded gradually toward the design specifications, each flight pushing a little faster, a little higher, gathering data that would inform adjustments and improvements. As testing progressed into 1963 and beyond, the A-12s began reaching speeds and altitudes that had never before been achieved by piloted aircraft. Flying at Mach 3.2 at altitudes above 80,000 feet, these machines traversed distances that would seem improbable to observers on the ground, covering a mile approximately every 2 seconds, crossing entire states in times measured in minutes rather than hours. The appearance of the aircraft was unlike anything in common experience, with its dark color and elongated form presenting a silhouette quite different from commercial airliners or military fighters. And because the A-12 operated under conditions of absolute secrecy, with its existence known only to those with specific clearances, there was no way for ordinary citizens who might glimpse these flights to understand what they were seeing. Reports began to accumulate in various official channels, accounts from airline pilots and ground observers describing objects in the sky that behaved in ways no known aircraft could manage. A dark shape seen at tremendous altitude, moving faster than anything reasonable, catching the sunlight at angles that conventional planes never achieved. Such sightings fed into the broader phenomenon of unidentified flying object reports that had been growing since the late 1940s. Citizens wrote letters to Air Force officials, filed reports with local authorities, spoke to newspaper reporters about what they had witnessed. They were not mistaken about what they had seen, in the sense that something had genuinely passed through their field of vision, but they lacked the context to interpret the observation correctly, and no one was in a position to provide that context without compromising highly classified operations. The investigators assigned to evaluate such reports found themselves in an awkward position, knowing in some cases exactly what had caused a particular sighting but unable to say so. The convenient explanation that swamp gas or temperature inversions or misidentified celestial bodies accounted for these observations became standard, not because investigators believed such explanations, but because no truthful alternative could be offered. This dynamic, in which genuine phenomena were deliberately obscured by official silence, contributed to a growing public suspicion that something was being concealed, a suspicion that was in fact entirely correct, though not for the reasons most observers suspected. The A-12 incorporated features that extended beyond its remarkable speed and altitude capabilities. The Skunk Works engineers, in collaboration with various government laboratories, developed materials and coatings intended to reduce the aircraft's visibility to radar's visibility to radar, an early form of what would later become known as stealth technology. Certain surfaces were treated with radar-absorbing compounds, and the overall shape of the aircraft was designed not only for aerodynamic efficiency, but also to minimize its radar cross-section. scattering incoming signals away from receivers rather than reflecting them directly back. These measures did not render the A-12 invisible to radar, but they significantly reduced the range at which it could be detected, providing an additional margin of safety beyond what speed and altitude alone could offer. The human cost of the program accumulated quietly over the years, as experimental aviation of this nature carries inherent risks that cannot be entirely eliminated. 7 pilots who flew the A-12 lost their lives in accidents during the program's operational period. Each loss a private tragedy observed by a small community of colleagues and family members, but recorded in no public document. The causes varied, as they do in any flight test program: mechanical failures, spatial disorientation, circumstances that even experienced investigators could not fully reconstruct. These men had volunteered for work they knew to be dangerous, and they conducted that work in obscurity, their contributions unacknowledged in any form that reached the wider world. Their names would not become publicly known for decades, their sacrifices held within the same classification barriers that protected every other aspect of the program. The base where these operations took place continued to expand throughout the 1960s, its footprint growing to accommodate the evolving needs of the programs it supported. New buildings rose from the desert floor, and existing facilities were modified or replaced as requirements changed. Yet, through all of this growth, the installation remained absent from any publicly available map or official listing. A place that existed in the physical world, but not in the documentary world that ordinary citizens could access. Mail sent to personnel stationed there bore fictitious return addresses, and families of workers were instructed to describe their loved ones' employment only in the vaguest terms. The discipline required to maintain this secrecy extended to every aspect of daily life, a constant, low-level awareness that casual conversation could compromise vital national interests. In this manner, the A-12 program proceeded through its development and eventual operational deployment. Its aircraft flying missions that remained classified long after the machines themselves were retired to museums and storage facilities. The titanium birds, as one might gently call them, had outrun not only missiles but also the understanding of those who watched them pass overhead, leaving only puzzlement and wonder in their wake. The answers to the questions these sightings provoked would remain unavailable for many years, locked within filing cabinets and secure computers, waiting for a time when disclosure would no longer threaten ongoing operations or methods. And the desert facility that had made all of this possible continued its quiet work, preparing for whatever might come next. Its purpose evolving as technology and geopolitics shifted around it. For many decades, the remote installation nestled within the Nevada desert existed in a peculiar state of quiet obscurity, known to relatively few people beyond those who worked there and the small number of government officials who oversaw its classified operations. The general public, going about their daily lives in cities and towns across America and indeed around the world, had little reason to know about this particular dry lake bed or the hangars and runways that had been constructed along its edges. There were no newspaper headlines drawing attention to its existence, no television programs speculating about what might be taking place behind its perimeter fences, and the name Area 51 itself carried no special significance to the average person who might have encountered it, if indeed they ever encountered it at all. This relative anonymity persisted through the 1950s, the 1960s, the 1970s, and much of the 1980s, during which time the facility continued its work on experimental aircraft, far from the curious gaze of those who might have wished to know more about it. The reasons for this prolonged obscurity were several, and they intertwined with one another in ways that proved quite effective at maintaining the facility's low profile. The location itself, deep within a vast military testing range that covered thousands of square miles of desert terrain, meant that ordinary civilians had no practical means of stumbling upon it during their regular travels or recreational activities. The nearest paved roads passed at considerable distances, and the unpaved routes that might have brought one closer were restricted and monitored. Those who did work at the facility were bound by security clearances and classification protocols that discouraged, quite strongly, any discussion of their employment or its particulars with family members, friends, or anyone else outside the cleared community. This culture of silence, maintained through legal agreements and professional expectations, proved remarkably effective at preventing information from seeping into the broader public consciousness. And so the years passed quietly. It was in the year 1989 that circumstances began to shift in ways that would prove quite significant for the facility's place in public awareness. Though, of course, at the time, no one could have predicted the full extent of what would follow. In that year, a man named Bob Lazar appeared on a Las Vegas television station called Class, where he was interviewed by a reporter named George Knapp, who had developed an interest in stories of unusual phenomena and unexplained events. Lazar, who was presented with his identity initially concealed and his face kept in shadow, made a series of claims that were, by any measure, extraordinary in their scope and implications, though we shall describe them here in the same measured tone we have maintained throughout, as this is not the place for heightened emotion or dramatic emphasis of any kind. According to the statements Lazar made during these interviews, he had been employed at a location he referred to S4, which he described as being situated near Papoose Lake, a dry lake bed located some miles to the south of the main Groom Lake facility that we have been discussing. At this location, Lazar claimed he had been tasked with studying and attempting to understand the propulsion systems of what he described as craft of extraterrestrial origin, vehicles that had supposedly been acquired by the United States government and were being kept in hangars built into the mountainside. He described the interiors of these craft, the materials from which they appeared to be constructed, and the principles by which he believed their propulsion systems operated. Speaking of gravity amplification and element 115, a substance that was not yet part of the periodic table as it was then known to science. It is important to note, as we continue in our unhurried way, that the claims made by Lazar during these interviews were never verified through any independent means, and significant questions arose regarding the credentials and background he had described. Lazar stated that he held degrees from the California Institute of Technology and the Massachusetts Institute of Technology, two of the most prestigious scientific institutions in the United States. Yet, when investigators and journalists attempted to confirm his attendance at these universities, they were unable to find records supporting his claims. Employment records that might have corroborated his description of his work history proved similarly elusive, and the scientific community largely did not embrace his accounts of exotic propulsion systems and materials with unusual properties. Some suggested that he had perhaps worked at or near the facility in some capacity, possibly as a contractor or in a peripheral role, while others questioned whether his entire narrative was a fabrication. The truth of the matter remains, to this day, unclear, and we need not resolve it here in order to continue with our peaceful narrative. What can be said with greater certainty is that the interviews conducted by George Knapp, regardless of one's assessment of their veracity, had a remarkable effect on public awareness of the facility and its surrounding area. The name Area 51, which had previously circulated only in limited circles, began to appear in conversations and publications with increasing frequency. People who had never given thought to military testing ranges in Nevada found themselves curious about this remote location and the activities that might or might not be taking place there. And this curiosity, once kindled, proved remarkably persistent. The late 1980s and early 1990s saw a gradual but unmistakable growth in public interest. And with that interest came individuals who wished to see the facility for themselves, or at least to see as much of it as was legally possible from public lands outside the restricted perimeter. This brings us to the gentle matter of the Watchers. As they came to be known, the community of curious individuals who gathered on the hillsides and ridgelines that offered distant views of the Groom Lake Basin. The most notable of these vantage points was a location known as Freedom Ridge, which rose to an elevation that permitted observers with binoculars or telescopes to gaze across the miles of desert toward the distant hangars and runways. Whitesides Mountain offered similar opportunities, and together these locations became gathering places for those whose curiosity had been stirred by the stories circulating in the media and through informal networks of enthusiasts. The people who made their way to these hillsides were, by all accounts, a varied and generally peaceable group. Some came with expensive camera equipment, hoping to photograph aircraft during test flights or to document the movements of vehicles along the distant roads. Others came simply to experience the landscape for themselves, to stand in the desert air and look toward the forbidden zone with their own eyes, satisfying a curiosity that television interviews and magazine articles could not fully address. There were researchers who carefully logged the times and dates of their observations, noting the types of aircraft they witnessed and any unusual characteristics of their flight patterns. There were also casual visitors, people on holiday who had heard stories and wished to add this experience to their collection of travels. They would arrive in cars and recreational vehicles, sometimes camping overnight in the desert, sharing meals and conversation as they waited for something interesting to appear above the distant ridgelines. The experience of watching from these hillsides was, by its nature, an exercise in patience and acceptance of limited information. The facility was many miles away, and even with optical assistance, the details visible to observers were quite limited. Aircraft might appear as small shapes against the sky, moving in ways that seemed unusual or entirely ordinary depending on one's expectations and interpretive framework. The watchers could not know with certainty what they were seeing, whether the craft before them were experimental military vehicles employing advanced but terrestrial technology, or something more exotic, as some hoped and suspected. This ambiguity was simply part of the experience, and those who gathered on the hillsides seemed, for the most part, content to observe and speculate without demanding definitive answers that were unlikely to be forthcoming. The period during which Freedom Ridge and Whitesides Mountain remained accessible to these informal observers lasted for several years, but it came to an end in 1995, when the United States Air Force took steps to acquire the land on which these vantage points were located. Through a process involving coordination with the Bureau of Land Management, which had previously administered these parcels as public land, the Air Force expanded the restricted zone surrounding the facility to include these hillsides. The effect was to push back the boundary beyond which curious observers could legally stand, removing the most advantageous viewpoints from public access and making it considerably more difficult to observe the facility's operations from outside the perimeter. Some among the watching community protested this expansion, arguing that it represented an unnecessary restriction on public lands. But the acquisition proceeded nonetheless, and the hilltops that had welcomed so many curious visitors fell quiet. We might turn now to the matter of how the personnel who work at this remote facility make their daily journeys to and from the site, a topic that has its own gentle interest for those who find satisfaction in the practical details of unusual operations. The facility, as we have noted, is situated many miles from any civilian population center, and the vast majority of those who work there do not reside in the immediate vicinity. Instead, they make their way to work each morning by means of an air service that has come to be known informally as Janet Airlines, a name that derives from the radio call signs used by the aircraft, which begin with the word Janet, followed by a flight number. The aircraft operated by this service are typically Boeing 737 passenger jets, painted in a distinctive white livery with a single red stripe running along the fuselage. They bear no airline logo or company name, and their tail numbers, while registered with civil aviation authorities, do not immediately reveal the nature of their operations to casual observers. These unmarked aircraft depart each weekday morning from a dedicated terminal at McCarran International Airport in Las Vegas, which has since been renamed Harry Reid International Airport, carrying their passengers northward to the restricted airspace above the Nevada desert. In the evening, the flights reverse their route, returning the workers to Las Vegas, where they resume their lives among the civilian population, bound by their clearances, to say nothing of where they have spent their working hours. The terminal from which these flights depart is situated apart from the main passenger terminals of the airport, and access to it is restricted to those with appropriate credentials. Travelers passing through Las Vegas on ordinary journeys may catch glimpses of the white aircraft parked at a distance, or observe them taking off and landing, but they cannot approach the terminal or interact with the passengers in any way. The workers who board these flights each morning are, by all appearances, ordinary people going about their professional lives, carrying briefcases and lunch containers, chatting with colleagues as they wait to board. What distinguishes them is simply the destination to which they travel and the nature of the work that awaits them there, matters about which they maintain a careful and practiced silence. Finally, we come to the small community of Rachel, Nevada, which has achieved a certain quiet fame as the nearest civilian settlement to the restricted zone. Rachel is, by any measure, a very small place, with a permanent population that has at times fallen below 100 residents. It sits along Nevada State Route 3755, which passes through the desert landscape some miles to the west of the facility, and which was officially designated as the Extraterrestrial Highway by the state of Nevada in 1996, a recognition of the area's unusual place in public imagination. The most notable establishment in Rachel is the Little Earl Inn, a small diner and motel whose name plays on the words alien and inn, and whose exterior is decorated with imagery relating to extraterrestrial themes. This modest establishment has become a gathering place for the curious visitors who make their way to this remote corner of Nevada, offering meals and accommodation and a selection of souvenirs related to the area's unusual reputation. The atmosphere is, by all accounts, friendly and unhurried, and the visitors who pass through range from serious researchers to casual tourists to those who simply enjoy the novelty of dining in such an unusual location. They sit at tables, consuming hamburgers and beverages, discussing what they have seen or hope to see, and then they continue on their journeys, leaving Rachel to its quiet existence under the wide desert sky. And now we arrive at a rather comforting portion of our journey through the history of Groom Lake, a section concerned not with speculation or rumor, but with documents that have been opened, with photographs that have been released, and with aircraft that once seemed impossible, but which we now know to have been the work of engineers and test pilots working in conditions of extraordinary secrecy. There is something quite soothing, I think, about the way mysteries resolve themselves when given enough time. The way that patience and the eventual declassification of records can transform the unexplainable into the entirely explicable, and how the strange lights witnessed by a rancher in the Nevada desert in 1983 might, decades later, be traced to a specific aircraft with a specific designation developed by specific people whose names now appear in aviation histories. Let us begin with what is perhaps the most famous of all the aircraft tested at Area 51, the Lockheed F-117 Nighthawk, that angular black shape that looks nothing like a conventional aeroplane and which represented, at the time of its development, a fundamental reimagining of what military aircraft could be. The program that would eventually produce the Nighthawk began in the early 1970s, when engineers at Lockheed's Skunk Works division, building upon theoretical work by a Soviet physicist named Pyotr Ufimtsev, began to explore whether an aircraft could be designed to evade radar detection not through electronic countermeasures, but through the careful shaping of its surfaces. The mathematics involved were enormously complex, requiring the calculation of how radar waves would reflect off every angle and curve. And the early computers of that era struggled to model anything but flat surfaces, which is why the F-117 emerged with its distinctive faceted appearance, all sharp angles and flat planes rather than the smooth curves of conventional aircraft. The first demonstrator aircraft, known as Have Blue, flew at Groom Lake in 1977, a small and fragile thing piloted by men who understood that they were testing something genuinely new. Have Blue was not meant to be a combat aircraft, but rather a proof of concept. a way of determining whether the stealth principles would actually work when applied to a real flying machine rather than a mathematical model. There were 2 HAV-Blue aircraft built, and both of them crashed, which gives you some sense of just how difficult and dangerous this early testing was. The first crashed in May of 1978 when a landing gear would not extend properly and the pilot, after attempting to jar it loose through maneuvers, eventually ejected safely. The second crashed the following year during a training flight when a hydraulic line caught fire. And in this case too, the pilot ejected, though he was injured and the aircraft was destroyed. What makes these crashes particularly interesting from the perspective of secrecy is the extraordinary lengths to which the Air Force went to recover the wreckage. The HAV-Blue aircraft were covered in special materials and coatings that were themselves classified, and the shapes of the aircraft were not to be seen by anyone without the proper clearances. And so recovery teams were dispatched immediately to gather every fragment, every piece of twisted metal, every component that might be lying in the desert scrub. The crash sites were cleaned with a thoroughness that seems almost obsessive until you consider that even a small piece of radar-absorbent material, if analyzed by a foreign intelligence service, might have revealed something about how the technology worked. Men walked shoulder to shoulder across the desert floor, picking up pieces of aircraft the way one might search for a lost contact lens in a large room, and satellite photographs of the crash sites were purchased and classified before anyone outside the program could see what had fallen from the sky. The success of HAV-Blue, despite the crashes, led to the development of the full-scale F-117 Nighthawk, and these operational aircraft began arriving at Groom Lake for testing in June of 1981. For nearly a decade, the Nighthawk remained completely secret, flying only at night from a specially constructed facility at Tonopah Test Range, some 70 miles northwest of Groom Lake. The pilots who flew these missions lived strange double lives, spending weekdays at Tonopah in conditions of absolute secrecy and then returning to their families on weekends, unable to discuss what they did for a living. The aircraft were kept in hangars during daylight hours, and the flight schedule was arranged so that they would take off after dark and land before dawn. And in this way, the most advanced tactical aircraft in the American arsenal was hidden in plain sight, or rather, hidden in plain darkness. During those years of secrecy, there were sightings, of course. People living near the test ranges would occasionally glimpse something that did not look like any aircraft they had seen before, and some of these witnesses reported their observations to newspapers or to organizations that collected accounts of unidentified flying objects. The F-117 was so unlike anything in the public consciousness of what an aeroplane should look like that it was, quite literally, unidentifiable to those who saw it. Its angular shape, its silent approach, the way it seemed to appear and disappear against the night sky. All of these characteristics made it seem otherworldly to observers who had no context for understanding what they were seeing. And so the sightings accumulated, became part of the folklore of the desert, were discussed by enthusiasts of the unexplained, until December of 1989, when the aircraft was finally revealed to the public, and all of those strange angular shapes in the Nevada night suddenly had a name. The F-117 was first used in combat during the American invasion of Panama in December of 1989. just days after its public unveiling, and it subsequently served in the Gulf War and in various other conflicts until its retirement in 2008. By that time, the technology that had seemed so revolutionary had been surpassed by newer developments, and the Nighthawk's angular facets had given way to the curved stealth surfaces of aircraft like the B-2 bomber and the F-22 Raptor. But for those of us interested in the history of Groom Lake, the F-117 remained significant as perhaps the clearest example of how extreme secrecy can transform an engineering project into a source of mystery, and how the passage of time can transform that mystery back into engineering. Now, let us turn our attention to an earlier chapter in the history of secret testing at Groom Lake, one that had nothing to do with American aircraft at all, but rather with aircraft built by the Soviet Union. In the early 1960s, American military planners faced a significant problem, namely that American pilots might at any moment find themselves in combat against Soviet aircraft, particularly the MiG-21 fighter, and yet those pilots had no opportunity to learn how such aircraft handled, what their strengths and weaknesses were, how to defeat them in a dogfight. The solution to this problem came when the United States managed to acquire, through various means that remain somewhat mysterious, actual Soviet-built MiG fighters that could be tested and studied. The program to evaluate these captured Soviet aircraft was given the name Havdonut when it began in 1968 at Groom Lake, using a MiG-21 that had been obtained from Israel, which had itself acquired the aircraft when an Iraqi pilot defected in 1966. The Havdonut evaluations revealed a great deal about the MiG-21 that American pilots had not known, including its remarkable turning ability at certain speeds and its less remarkable rearward visibility. And this information was eventually incorporated into American fighter pilot training. A subsequent program, HAV-Drill, continued these evaluations and expanded them to include additional Soviet aircraft types. And the information gathered proved invaluable when American pilots encountered these same aircraft in the skies over Vietnam. What makes these programs relevant to our discussion is that the MiG fighters being tested at Groom Lake were, to any observer who happened to glimpse them, then aircraft that simply did not exist in the American inventory. A rancher or a miner who caught sight of a MiG-21 being put through its paces over the Nevada desert in 1969 would have seen something genuinely foreign, something with an unfamiliar silhouette and unfamiliar markings. And it would have been entirely reasonable for such an observer to conclude that they were seeing something that could not be explained by any conventional understanding of what the American military was doing. And yet, there was, of course, a perfectly mundane explanation, one that simply could not be discussed at the time. The tradition of testing captured foreign aircraft at Groom Lake continued for many years and expanded to include not just Soviet fighters, but also surface-to-air missile systems and other military hardware that American forces might encounter in combat. The facility became, in essence, a place where the unknown could be made known, where the capabilities of potential adversaries could be studied and understood and ultimately countered. All of this work was conducted in secret, and all of it contributed to the aura of mystery that surrounded the base, and all of it has now been largely declassified and entered into the historical record. Let us also consider the D-21, a supersonic reconnaissance drone that represents one of the more extraordinary aircraft ever tested at Groom Lake, though its operational career was brief and marked by failure. The DD-21 was designed to fly over heavily defended targets at speeds exceeding Mach 3, photographing installations that were too dangerous for piloted aircraft to approach, and then jettisoning its camera payload for recovery while the drone itself was destroyed. The original plan called for the DD-21 to be launched from the back of an M21, which was itself a modified version of the A-12, the predecessor to the State Route 71 Blackbird. And this arrangement meant that the drone would begin its mission already traveling at high altitude and high speed. The testing of the D-21 at Groom Lake in the mid-1960s was challenging, and in July of 1966, a launch attempt ended in disaster when the drone collided with the mothership, killing one of the two crew members aboard the M21. After this accident, the launch method was changed, and subsequent D-21 drones were carried aloft by B-52 bombers and launched using rocket boosters. The D-21 was eventually used operationally over China, where it was intended to photograph Chinese nuclear facilities. But none of these missions were successful, with drones crashing or failing to return their camera payloads, and the program was cancelled in 1971. The existence of the D-21 remained classified for many years, and the wreckage of at least one drone was recovered by the Chinese and studied, though this fact too was not publicly known until much later. Moving forward in time, we come to the Boeing Bird of Prey, a technology demonstrator that was tested at Groom Lake between 1996 and 1999, and whose existence was not revealed to the public until October of 2002. The Bird of Prey, named after the Klingon spacecraft from the Star Trek television series, was designed to test various stealth and manufacturing technologies, including single-piece composite construction and active camouflage systems. It was a small aircraft, with a wingspan of just 23 feet, and it flew only 38 times during its 3 years of testing. But it represented a continuing tradition of developing and evaluating radical new aircraft concepts at the remote desert facility. What is perhaps most notable about the Bird of Prey, from our perspective, is the length of time between its retirement and its public revelation. The aircraft made its final flight in 1999. But the program remained classified for another 3 years, during which time anyone who had happened to glimpse it would have been left to wonder what they had seen. This gap between testing and disclosure is characteristic of programs conducted at Groom Lake, and it means that at any given moment there may be aircraft flying over the Nevada desert that will not be publicly acknowledged for another 5 or 10 or 20 years. The sightings that occur in the meantime become, inevitably, part of the accumulating folklore of the unexplained. Finally, let us consider a more recent example, the RQ-170 Sentinel, a stealth unmanned aerial vehicle that was almost certainly tested at Groom Lake before its existence became publicly known in a rather unexpected way. The Sentinel was first spotted by civilian observers in Afghanistan in 2009, where it was photographed sitting on a runway at Kandahar Airfield. But its existence was not officially acknowledged by the Air Force until later. The aircraft became considerably more famous in December of 2011, when one crashed, or was brought down, in Iran, and was subsequently displayed by Iranian authorities as evidence of American espionage activities. The RQ-170 represents the continuation of a long tradition of unmanned reconnaissance aircraft, stretching back to the D-21 and beyond, but its bat-winged shape and its radar-evading characteristics are clearly descended from the stealth technology that was first proven at Groom Lake with the HAV Blue demonstrators more than 3 decades earlier. And like so many of the aircraft tested at that facility, the Sentinel spent some portion of its development hidden from public view, flying over the desert at times and in ways that were not recorded in any publicly accessible log, contributing to the pool of unexplained sightings that characterizes the region. And so we come to the gentle conclusion that emerges from all of these histories, which is that each generation of impossible sightings has, given enough time, yielded to mundane explanation. The angular shapes in the night sky of the 1980s were F-117 Nighthawks. The foreign silhouettes of the 1960s were captured MiG fighters. The strange high-altitude craft of other decades were reconnaissance platforms and technology demonstrators whose purposes and capabilities were classified, but whose origins were entirely terrestrial. This pattern is, I think, rather comforting, because it suggests that the universe is less mysterious than it sometimes appears, or rather, that the mysteries are human mysteries, the products of secrecy and engineering and the desire of nations to know what their adversaries are doing. The skies over Groom Lake continue to hold secrets, of course, because the testing of classified aircraft continues there to this day. And there are almost certainly aircraft flying over that desert right now whose existence will not be acknowledged for another decade or more. But we can say, with some confidence, that when those aircraft are eventually revealed, they will be aircraft designed by engineers, built in factories, flown by pilots or by autonomous systems, and subject to the same laws of physics that govern everything else that moves through the atmosphere. This is not a disappointing conclusion, but rather a reassuring one, a reminder that the boundaries of the known are always expanding, slowly and steadily, like the gentle spreading of dawn light across a desert floor. And that patience, more than anything else, is what transforms the unexplained into the explained. And with that comforting thought, we may allow our minds to drift and settle, like dust motes in still air, knowing that the answers, when they come, are always simpler than the questions suggested. The science of making things disappear begins, as so many quiet revolutions do, with mathematics written in a language that few could read, published in a country that few in the West were watching. In 1962, a Soviet physicist named Pyotr Yakovlevich Ufimtsev completed a monograph on the behavior of electromagnetic waves as they encounter objects of various shapes, a work he titled Method of Edge Waves in the Physical Theory of Diffraction. The book was dense with equations that described how radio waves, and by extension radar beams, would scatter when they struck edges and surfaces of different geometries. Soviet authorities, reviewing the manuscript, concluded that its contents were too theoretical, too abstract, too far removed from practical engineering to warrant classification. And so the book was published openly, and a few years later, translated into English by the Air Force Foreign Technology Division, where it sat in technical libraries, read by almost no one, gathering the particular kind of dust that settles on documents whose significance has not yet been recognized. What Ufimtsev had done, in his patient and methodical way, was provide the mathematical tools for predicting precisely how much radar energy an object would reflect back toward the radar that illuminated it, based purely on the shape of that object's surfaces and edges. This quantity, the radar cross-section, had always been understood in general terms. Engineers knew that large, flat surfaces perpendicular to a radar beam would return strong echoes, much like a mirror reflects light directly back at you when you stand before it. They understood that curved surfaces and irregular angles would scatter reflections in many directions, reducing the energy that returned to the receiver. But Ufimtsev's equations allowed for something new, something that had seemed nearly impossible before. They permitted designers to calculate, with considerable accuracy, exactly what shapes would minimize radar return from specific angles, and to do so before building anything at all, working only with pencil and paper and, eventually, with the computational power of early computers. More than a decade would pass before an engineer at Lockheed's Advanced Development Projects Division, the facility informally known as the Skunk Works, retrieved Ufimtsev's translated papers and recognized their implications. That engineer, Denny Overholser, understood that the equations could be inverted, so to speak, used not merely to predict how much radar energy a given shape would reflect, but to design shapes specifically optimized to reflect as little energy as possible back toward any threatening radar. The aircraft that emerged from this insight would not look like any aircraft that had come before. The familiar curves and flowing lines that made aeroplanes beautiful and aerodynamically efficient would be replaced by something stranger, something that appeared almost primitive, as if assembled from flat plates and sharp angles rather than sculpted by wind. This was the origin of the F-117 Nighthawk, though it would be many years before the public learned its name or saw its peculiar silhouette. The aircraft's surfaces were composed of flat, triangular, and trapezoidal panels, joined at angles carefully calculated to deflect radar waves away from their source rather than back toward it. From most perspectives, the F-117 resembled nothing so much as a flying diamond, or perhaps a geometric abstraction of a bird folded from black paper. Its appearance was not merely unusual. It was the direct and visible consequence of Ufimtsev's mathematics rendered in metal and composite materials. Each facet served a precise purpose in the larger geometry of invisibility, directing radar energy downward, sideways, anywhere except the direction from which it had arrived. But shape alone, however carefully calculated, could not render an aircraft truly invisible to radar. The flat panels reduced reflection from the aircraft's skin. Yet radar waves are persistent things, finding their way into gaps and cavities, bouncing off engine turbine blades and cockpit interiors, scattering from joints and seams where panels meet. The engineers at Lockheed and elsewhere addressed these secondary reflections through the application of radar-absorbing materials, substances designed to convert radar energy into tiny amounts of heat rather than reflecting it back toward the receiver. These materials, often composed of carbon-impregnated polymers or iron ball-laden paints, work through a process called resistive absorption, in which the oscillating electromagnetic fields of the radar wave cause electrons in the material to move back and forth, generating friction at the molecular level, dissipating the wave's energy as thermal motion far too slight to detect. The development and testing of these materials, along with the airframes designed to carry them, required facilities far from curious eyes, places where strange shapes could take to the sky without prompting questions, where radar signatures could be measured and analyzed without interference from civilian air traffic or foreign observation. The test range in Nevada, the one that came to be known by many names, including Area 51 and Groom Lake and Homey Airport, provided exactly this environment. Its remote location in the desert basin, surrounded by restricted military ranges and mountain barriers, allowed engineers to evaluate how well their calculations translated into reality, flying prototype aircraft against test radar systems, measuring the faint returns, refining the geometry and materials until the signatures approached the theoretical minimums. The challenges of invisibility extended beyond radar into other regions of the electromagnetic spectrum. Aircraft generate heat, considerable amounts of it, particularly in their engines and in the exhaust plumes that trail behind them during flight. This heat radiates outward as infrared energy, the same kind of energy that makes warm objects visible to night vision devices and heat-seeking missiles. Reducing an aircraft's infrared signature proved in some ways more difficult than reducing its radar signature, because the laws of thermodynamics cannot be circumvented through clever geometry alone. An engine that burns fuel will produce hot gases, and those gases must go somewhere. The engineers working on stealth aircraft developed several approaches to this problem, none of them perfect, all of them representing careful compromises. Exhaust systems were designed to mix hot gases with cooler ambient air before releasing them, diluting the thermal signature. Exhaust nozzles were flattened and widened, spreading the heat over a larger area to reduce the intensity at any single point. Some designs positioned the engines above the wings or fuselage, using the aircraft's structure to shield the hot exhaust from observers below. The surfaces of the aircraft were sometimes treated with coatings that reduced their emissivity, their tendency to radiate absorbed heat back into the environment. And flight profiles were planned to minimize the time spent in vulnerable configurations, avoiding situations where hot engine components would be directly visible to potential threats. Beyond stealth, the remote Nevada facility has served as a proving ground for other technologies that push against the boundaries of conventional aeronautics. Hypersonic flight, the realm of speeds exceeding 5 times the speed of sound, presents engineering challenges so severe that much of the work remains experimental even today. At such velocities, the air itself becomes a hostile medium, heating the surfaces of any vehicle passing through it to temperatures that can soften or melt conventional materials. The compression of air ahead of a hypersonic craft generates shock waves that interfere with propulsion and control. Traditional jet engines, which rely on rotating compressors and turbines, cannot function at these speeds, their mechanical components unable to survive the conditions. The solution pursued by researchers, both at Area 51 and at other classified and unclassified facilities, is the scramjet, the supersonic combustion ramjet, an engine with no moving parts at all. A scramjet captures air rushing into its inlet at supersonic speeds, compresses it through carefully shaped internal channels, injects fuel into the supersonic airflow, and ignites the mixture, all while the air continues moving faster than the speed of sound throughout the entire process. This is extraordinarily difficult to achieve, like trying to light a match in a hurricane, as one engineer reportedly described it. The fuel must mix with the air and combust in a tiny fraction of a second before the airflow has passed through the combustion chamber entirely. The chamber walls must withstand temperatures approaching those found on the surface of the Sun. The vehicle must first be accelerated to hypersonic speed by some other means, a rocket or a carrier aircraft, before the scramjet can begin to function at all. Experimental hypersonic vehicles have been tested over restricted ranges for decades. Their unusual flight characteristics and extreme speeds, sometimes generating reports of aerial phenomena that observers could not readily explain. An aircraft accelerating through Mach 5 or Mach 6 behaves in ways that seem impossible to witnesses accustomed to conventional aviation, appearing to move in discontinuous jumps as it passes from one visible position to another faster than the eye can track, generating shock waves and plasma effects that may be visible under certain lighting conditions. The secrecy surrounding such programs ensures that no explanations are forthcoming when witnesses report what they have seen, and so the observations enter the folklore of the unexplained, their mundane origins classified and unavailable. Electronic warfare represents another domain of invisible technology developed and refined in Nevada's restricted airspace. Modern aircraft carry systems designed not to avoid radar detection entirely, which may be impossible against sufficiently sophisticated sensors, but to deceive and confuse the radar systems that detect them. These electronic countermeasures can generate false targets, convincing radar operators that they are tracking multiple aircraft when only one exists, or that an aircraft is in one location when it is actually in another. They can jam radar receivers with noise, overwhelming the faint return signals with electronic static. They can detect the radar beams illuminating an aircraft and precisely match their frequency and timing, injecting false information into the reflected signal to mislead tracking systems about range, bearing, or velocity. The physics underlying these techniques draws on the same electromagnetic principles that govern radar itself. A radar system sends out pulses of radio energy and listens for echoes, measuring the time delay to determine distance and the frequency shift to determine speed. An electronic warfare system intercepts these pulses, analyses them in microseconds, and generates responses calculated to exploit the radar's assumptions about how echoes should behave. The result is a form of technological sleight of hand, a manipulation of the electromagnetic environment so complete that observers cannot trust what their instruments tell them. The secrecy infrastructure surrounding Area 51 itself represents a kind of invisibility, a systematic effort to control information flow so thoroughly that the facility's activities remain unknown, even as the facility itself sits in plain view of passing satellites. The restricted airspace, designated R4808N, extends from the surface to unlimited altitude, prohibiting any unauthorized aircraft from approaching. The surrounding land is withdrawn from public access under national security provisions, monitored by ground sensors that detect approaching vehicles or individuals long before they reach any fence line. Warning signs mark the boundaries, their bland legal language conveying serious consequences for trespass. For decades, the United States government declined to acknowledge that the facility existed at all, responding to direct questions with neither confirmation nor denial. This posture became increasingly untenable as commercial satellite imagery improved. As former employees aged into retirement and began to speak of their experiences, as journalists and historians pieced together the outlines of programs that had been conducted there. In 2013, the Central Intelligence Agency declassified a substantial history of the U-2 reconnaissance aircraft program, a document that matter-of-factly referred to the test site at Groom Lake and included maps showing its location. This was the first official acknowledgement that Area 51 existed, arriving more than 50 years after the first experimental aircraft had flown from its runways. The physics of invisibility, whether applied to aircraft evading radar or to facilities evading public knowledge, operates through the same fundamental principle: the careful management of information. A stealth aircraft succeeds not by eliminating radar reflections entirely, which is impossible, but by reducing them below the threshold that a radar system can reliably distinguish from noise. A classified program succeeds not by eliminating all evidence of its existence, which is equally impossible, but by controlling the flow of information so that what reaches outside observers is fragmentary, confusing, deniable. Humans have learned to bend light and radar, to shape electromagnetic waves as a potter shapes clay, to craft illusions so complete that trained observers doubt their own instruments. The mathematics that makes this possible began in a Soviet physicist's quiet office, migrated through translation and obscurity to an American engineer's desk, and ultimately took flight as angular black shapes over the Nevada desert, visible to the eye but nearly invisible to the electronic sentinels watching the skies. These are genuine wonders, achievements of physics and engineering that required no extraterrestrial assistance, only human ingenuity applied with patience and considerable funding to problems that once seemed insoluble. The shapes that fly through restricted airspace may appear exotic, even impossible, but they are the products of equations and wind tunnels and countless hours of testing. Each strange angle and unusual material, the answer to a specific technical question about how waves behave when they encounter matter. The science is wondrous enough without embellishment. And the desert keeps its secrets not through magic, but through mathematics, and fences, and the carefully cultivated habit of official silence. And now we come to the part of our story where we must speak honestly about what we do not know, which is, in its own quiet way, the most interesting part of all. For the history of human understanding has always been a gradual process of replacing mystery with knowledge, and there remain, still, certain phenomena observed in the skies above Nevada and elsewhere that have not yet yielded to explanation, and this is not a cause for anxiety or excitement, but simply a statement of how things are. as ordinary and as peaceful as noting that there are depths of the ocean we have not yet explored, or distant galaxies whose light has not yet reached our instruments, and the mountains that surround the test site continue to hold their silences, as mountains do, indifferent to our curiosity, ancient in their patience. In December of 2017, the New York Times published a report that confirmed something many had long suspected, which was that the United States government had been quietly studying unidentified aerial phenomena through a program that came to be known as the Advanced Aerospace Threat Identification Program, or AATIP for short. And this program had operated from 2007 to 2012 with a budget of approximately $22 million. A sum that sounds substantial until you consider that it represents a tiny fraction of the overall defense budget, barely enough to fund a few modest research contracts and employ a small team of investigators. And the program had been initiated largely through the efforts of Senator Harry Reid of Nevada, who had a long-standing interest in aerospace matters and who believed, reasonably enough, that unexplained objects in controlled airspace warranted at least some formal attention from those responsible for national defense. The revelation of this program was notable not for what it concluded, because it concluded very little definitively, but for what it represented, which was an official acknowledgement that trained military observers had encountered phenomena they could not explain using conventional frameworks, and that the government had taken these encounters seriously enough to dedicate resources to their study. And this is perhaps the most important thing to understand about the current state of official inquiry into unidentified aerial phenomena, that it proceeds not from belief or disbelief, but from a pragmatic recognition that unexplained objects in sensitive airspace represent, at minimum, a matter worth investigating, regardless of what their ultimate explanation might turn out to be. And the investigators approach their work with the same methodical patience that characterizes any serious inquiry, gathering data, interviewing witnesses, analyzing sensor readings, and attempting to match observations with known aircraft, atmospheric phenomena, or equipment malfunctions. 3 videos in particular emerged into public awareness during this period, having been captured by Navy pilots and eventually declassified and officially released by the Department of Defense. And these videos carry the names Gimbal, Go Fast, and FL Vial 1, names that sound rather technical and unpoetic, as military designations often do, and each of them shows imagery captured by the infrared targeting systems of fighter aircraft, showing objects that the pilots at the time found puzzling and that have not been definitively identified in the years since. And if you were to watch these videos, which are freely available and quite brief, you would see grainy thermal imagery of objects moving against the sky or sea, and you would hear the voices of the pilots expressing surprise at what they were observing. And you would perhaps understand why these encounters prompted the pilots to file reports, and why those reports eventually prompted the establishment of more formal inquiry processes. The video called FLIR-1, which was recorded in 2004 during an encounter off the coast of San Diego, shows an oblong object that the pilots tracked for some time and that appeared to move in ways they found unusual. And the video called Gimbal, recorded in 2015 off the East Coast, shows an object that appears to rotate while maintaining its flight path. And the video called Go Fast, also from 2015, shows an object skimming above the ocean surface at what the pilots believed to be considerable speed. And in each case, the pilots were experienced professionals, flying some of the most advanced aircraft in the world, equipped with sophisticated sensor systems, and they were unable to identify what they were observing, which does not mean the objects were extraordinary in any particular way, only that the available data was insufficient to reach a conclusion. And insufficient data is itself a very ordinary thing, as common in scientific inquiry as it is in daily life. In 2010, the Department of Defense established the Unidentified Aerial Phenomena Task Force, which was later reorganized and renamed several times, as government entities often are. And the purpose of this task force was to standardize the collection and analysis of reports from military personnel who encountered unexplained objects, because it had become apparent that many such encounters were not being formally reported at all, either because pilots were unsure of the proper procedures or because they worried about the stigma that might attach to filing such reports. And the establishment of formal reporting mechanisms represented an attempt to gather more complete data, on the reasonable assumption that more data would eventually lead to better understanding. And the task force operated with the same unhurried patience that characterizes most bureaucratic endeavors, collecting reports, cataloging observations, and attempting to identify patterns that might point toward explanations. In 2023, NASA released a report on unidentified anomalous phenomena, as they had come to be called, and this report was notable primarily for its emphasis on the limitations of available data, explaining that the vast majority of reported sightings lacked the kind of detailed, multi-sensor observations that would be necessary to reach firm conclusions about what had been observed, and the report recommended the establishment of better data collection protocols and the integration of civilian scientific expertise into the analysis process. And it emphasized that the study of anomalous phenomena should be approached with the same rigorous methodology that governs any other scientific inquiry, neither dismissing reports out of hand nor accepting extraordinary explanations without extraordinary evidence. And the tone of the report was measured and careful, as scientific reports tend to be, acknowledging uncertainty without anxiety and proposing methodical steps toward better understanding. The way that scientists approach questions of this kind is worth dwelling on for a moment, because it differs in important ways from how such questions are often discussed in popular culture, where one is expected to either believe or disbelieve in various possibilities, as though the matter were a question of faith or allegiance rather than evidence and analysis. But the scientific approach is quite different, requiring neither belief nor disbelief, only a patient willingness to follow the evidence wherever it leads, and to acknowledge honestly when the evidence is insufficient to lead anywhere at all. And this is a more comfortable position than it might initially seem, because it relieves one of the burden of having to hold opinions about matters where opinions are not yet warranted. And it allows one to sit peacefully with uncertainty, treating unknown things as simply unknown, neither frightening nor exciting, just not yet understood. One example of this scientific approach in action can be found in the work of Avi Loeb, an astronomer at Harvard University who has devoted considerable attention to the question of how one might study anomalous aerial phenomena using rigorous scientific methodology. And Loeb founded an initiative called the Galileo Project, named after the astronomer who first turned a telescope toward the heavens and thereby transformed our understanding of the cosmos. And the Galileo project aims to construct a network of instruments capable of capturing high-quality, multispectral data on any unusual objects that might pass through their field of view. Because one of the fundamental limitations of existing data is that most sightings are captured by instruments designed for other purposes, like the targeting systems of military aircraft, which are optimized for tracking known threats rather than characterizing unknown phenomena. And Loeb argues, reasonably enough, that if we want better answers, we need better questions. And better questions require better data. And better data requires purpose-built instruments operated according to scientific protocols. What is interesting about Loeb's approach is not any particular conclusion he has reached. Because the project is still in its early stages and has not yet produced definitive findings, but rather his insistence that the question of what these phenomena might be is a scientific question that deserves scientific attention, and that the proper response to mystery is not to ignore it or to leap to conclusions, but to study it with patience and care, gathering data over time and allowing understanding to emerge gradually, as it always does in science. And this is a very gentle way of approaching the unknown, treating it not as a threat to be feared or a puzzle to be solved urgently, but as an invitation to curiosity, a reminder that there are still things in the world that we do not understand, which is, when you think about it, a rather beautiful state of affairs. The history of science is full of phenomena that were once mysterious and are now well understood, from the wandering stars that the ancients observed and that we now know to be planets orbiting the sun according to precise mathematical laws, to the strange lights that sometimes dance in the northern skies and that we now understand to be the interaction of solar particles with the Earth's magnetic field, to the curious fossils embedded in rock that once puzzled natural philosophers, and that we now recognize as the remains of creatures that lived millions of years ago. And each of these mysteries was eventually resolved, not through sudden revelation, but through the gradual accumulation of observations, the careful formulation of hypotheses, the patient testing of predictions, and the slow construction of explanatory frameworks that made sense of what had previously seemed inexplicable. And there is every reason to suppose that the aerial phenomena currently under study will eventually be understood in similar ways. Perhaps sooner, perhaps later, but eventually, because that is how human understanding works, advancing step by step, generation by generation, each small insight building on those that came before. In the meantime, the desert keeps its silences, as it has always done, the mountains rising in their ancient patience, the restricted airspace marked on maps with the same matter-of-fact precision used to mark rivers and highways. And the work continues, not with urgency or anxiety, but with the same steady persistence that characterizes all worthwhile human endeavors. The engineers testing their aircraft, the scientists analyzing their data, the administrators filing their reports, and the sun rising and setting over the dry lake beds and the creosote flats, as it has done for millennia and will continue to do for millennia more, indifferent to our questions and our answers alike. What still hides behind the mountains is, in the end, simply what we have not yet learnt, which is to say, it is not so different from the countless other things that await our understanding, the depths of the oceans, the interiors of distant planets, The workings of consciousness, the origins of life, all of the mysteries that persist, not because they are inherently unknowable, but because we have not yet developed the tools and techniques and conceptual frameworks necessary to understand them. And this is a peaceful thought, when you consider it carefully, because it means that the unknown is not a fixed quantity, but a horizon that recedes as we advance, always present, but always changing, always offering new questions to replace the old ones, new invitations to curiosity, new reasons to continue the patient work of understanding. And so we come to rest here, in the acknowledgement of what we do not know, which is considerable, and in the appreciation of the methods by which we might someday come to know it, which are patient and rigorous and unhurried, and in the recognition that mystery itself is not something to be feared, but something to be appreciated. A reminder that the universe is larger than our understanding of it, and that there is always more to learn. And the mountains keep their silences, and the stars wheel overhead in their ancient patterns, and somewhere in the desert night, an owl calls and falls silent, and the world continues its slow turning. And there is nothing to worry about, and nothing to fear, and plenty of time, all the time in the world, to let understanding come gradually, as it always does, like dawn spreading slowly across the distant ranges, illuminating first the peaks, then the slopes, then the valleys below, until at last the whole landscape is visible in the clear morning light. And now, as we have spent some time considering the documents and the timelines and the careful administrative history of this place, let us return once more to the landscape itself, to the quiet basin where all of these stories have unfolded. And let us do so at the most peaceful hour, when the Nevada desert settles into its deepest stillness. Somewhere in those hushed hours after midnight, when even the distant facilities have dimmed their lights and the security patrols have completed their rounds, and the whole vast expanse of Groom Lake rests beneath the enormous dome of the night sky. If you were to stand at the edge of this dry lake bed in those quiet hours, far from any artificial light, far from the glow of Las Vegas to the south or the scattered towns to the north, you would find yourself in one of the darkest places remaining in the continental United States. A place where the atmosphere is thin and dry and remarkably transparent, where the lack of moisture in the air means that starlight travels those final miles to your eyes with unusual clarity, undimmed by the humid haze that softens the skies over wetter regions. And in this exceptional darkness, you would witness something that most humans throughout history considered ordinary, but that has become rare for those of us who live beneath the orange glow of modern cities. Something so simple and yet so profound that it hardly needs description. And that is the Milky Way in its full and gentle splendor, arching across the sky from horizon to horizon like a river of soft light. The stars above the Nevada desert on a clear night number in the thousands visible to the unaided eye, perhaps 3,000 or more depending on the conditions, each one a distant sun burning with nuclear fire, each one separated from its neighbors by distances so vast that light itself, traveling at 186,000 miles per second, requires years or decades or centuries to cross the gaps between them. And yet, from our vantage point on this small planet, they appear as a peaceful scattering of gentle points, some brighter, some dimmer, some with the faint reddish or bluish tints that hint at their different temperatures and ages. all of them hanging in perfect stillness against the velvet darkness, patient and unhurried, asking nothing of us but perhaps inviting us in, if we are quiet enough to notice, to consider our place among them. These are the same stars, or very nearly the same stars, that humans have wandered beneath for millennia. The same patterns that ancient peoples traced into constellations and wove into stories. The same lights that guided sailors across dark oceans and that shepherds watched while tending their flocks through long nights. The same cosmic backdrop that has witnessed every chapter of human history, from the first cave paintings to the construction of pyramids, to the signing of treaties, to the secret development of aircraft in remote desert basins. And the stars have remained indifferent to all of it, burning steadily through events that seemed monumentally important to the humans experiencing them, but that register as less than an eye blink in the timescales over which stars live and die. As you stand there in the darkness, feeling perhaps the slight chill that descends upon the desert after sunset, when the day's heat radiates back into the clear sky, you might reflect on the rather humbling fact that the ground beneath your feet is not as stationary as it seems, that our planet is rotating on its axis at roughly 1,000 miles per hour at the equator, carrying you and the dry lake bed and the distant mountains and everything else along with it in a smooth and imperceptible motion. So smooth that you cannot feel it at all, though it is the reason the stars appear to wheel slowly across the sky as the night progresses, rising in the east and setting in the west, tracing ancient arcs that have remained essentially unchanged for as long as humans have been watching. And the rotation is only the beginning, only the first and smallest of the motions in which we are embedded. Because the Earth is also orbiting our Sun at approximately 67,000 miles per hour, following an elliptical path that takes 1 year to complete, carrying us through the seasons as we swing closer and then further from our star. And this orbital speed is so great that in the time it takes you to read this sentence, the Earth has traveled perhaps 1,000 miles through space, though of course you feel none of this motion either, because everything around you, the air and the ground and the mountains on the horizon, is traveling along with you at precisely the same velocity. Our Sun itself, that modest yellow star that provides the warmth and light upon which all terrestrial life depends, is not stationary either, but is moving through the galaxy at roughly 450,000 miles per hour, carrying the Earth and all the other planets along with it, tracing a long, slow orbit around the center of the Milky Way, an orbit so vast that it takes approximately 230 million years to complete a single circuit, which means that the last time our solar system was in this approximate region of the galaxy, dinosaurs had not yet evolved, and the continents were arranged in configurations that would be unrecognizable to modern geographers. The Milky Way itself, that soft river of light overhead, is our galaxy, a collection of approximately 200 billion stars bound together by gravity into a great spiral structure roughly 100,000 light-years across. And we are located within one of the spiral arms, about 2/3 of the way out from the galactic center, surrounded by neighboring stars that are themselves orbiting that distant core, all of us embedded within this slowly rotating cosmic pinwheel. And even the galaxy is not stationary, but is moving through the universe, approaching our nearest large galactic neighbor, the Andromeda Galaxy, at roughly 250,000 miles per hour, though the distance is so great that the collision, or more accurately, the merger, will not occur for another 4 billion years or so. If you were to look up from the Nevada desert and locate the Andromeda Galaxy, which appears to the naked eye as a faint fuzzy patch of light in the constellation that bears its name, you would be seeing light that left that galaxy approximately 2.5 million years ago. Light that began its journey across the intergalactic void long before modern humans existed. Long before our ancestors had developed language or tools or the capacity to wonder about distant lights in the sky. And that light has been traveling ever since, crossing the vast emptiness between galaxies at the fastest speed the universe allows. And only now, in this particular moment, is it arriving at your eyes, carrying information about what Andromeda looked like when our earliest human ancestors were just beginning to walk upright on the African savanna. This is the cosmic context within which all human activities occur, including the activities that have taken place at the dry lake bed known as Groom Lake, including the development of aircraft that pushed the boundaries of what was thought possible, including the decades of secrecy and speculation and official acknowledgements and continuing mysteries. All of it unfolding on a small planet orbiting a modest star in an unremarkable region of one galaxy among 2 trillion galaxies in the observable universe. And when considered from this perspective, the specific details of what flew above that desert basin, whether it was the U-2 or the A-12 or something experimental that remains classified, or something that has never been adequately explained, these details retain their interest and their importance to us as curious beings. But they also take their proper place within a much larger frame, a frame so vast that it humbles every human certainty. Whatever craft were tested above that quiet basin, whatever objects were observed by pilots or detected by radar or reported by witnesses whose accounts have never been satisfactorily resolved, these things existed and perhaps continue to exist within the same universe that contains the Andromeda Galaxy and the cosmic microwave background radiation left over from the earliest moments after the Big Bang, and the dark matter that holds galaxies together, and the dark energy that is causing the expansion of the universe to accelerate. A universe that is approximately 13.8 billion years old, and that contains more galaxies than there are grains of sand on all the beaches of Earth. And this universe has been here long before humans evolved the capacity to build secret test facilities or wonder about unidentified objects in the sky. And it will continue long after our species has run its course, whatever that course may be. The stars that shine over the Nevada desert tonight are the same stars that shine over every other location on Earth, the same stars that ancient humans watched from African grasslands and Pacific islands and frozen tundra and river valleys where the first civilizations arose. The same stars that have witnessed every question humanity has ever asked and every answer we have ever proposed. And they offer no judgment on our questions or our answers, no confirmation of our theories and no refutation of our doubts, only their steady ancient light, traveling across the years and the parsecs to reach our small corner of the cosmos. Mystery, when considered in this light, is not something threatening or unsettling, not something that should keep us awake with anxiety or fill us with dread about what might be unknown, but rather something entirely natural and perhaps even comforting. Because the universe has always contained more than we could explain, and it likely always will. And this is not a failure of human understanding, but simply an accurate recognition of our position within an immensity that exceeds comprehension. And the appropriate response to mystery is not fear, but wonder. Not anxiety, but curiosity. Not the desperate need for immediate answers, but the patient willingness to keep asking questions across generations and centuries, and perhaps millennia. The dry lakebed of Groom Lake will continue to rest beneath the stars, as it has for thousands of years. And the questions that have accumulated around that place will continue to evolve as new information emerges and old certainties are revised, and the long, slow process of understanding proceeds at its own unhurried pace. And perhaps someday many of the mysteries will be explained in terms that satisfy our curiosity. Or perhaps some of them will remain unexplained for reasons we cannot yet foresee. And either outcome is acceptable. Either outcome is part of the natural relationship between curious beings and the vast cosmos that contains them. And so, as you settle more deeply into the gentle rhythms of approaching sleep, you might imagine yourself drifting upward from that quiet basin, rising slowly above the desert floor, past the mountain ranges that ring the valley, past the thin, high clouds that sometimes streak the Nevada sky, past the upper atmosphere where the stars shine with even greater clarity, rising into that peaceful darkness where the earth curves gently below and the sun illuminates the far side of the planet, while this side rests in shadow. And from that vantage point, you can see how small and precious our world is, how delicate the thin shell of atmosphere that separates us from the vacuum of space. How remarkable it is that on this one small planet, in this one small corner of one galaxy among trillions, there evolved beings capable of wondering about the universe and building aircraft to explore the sky and asking questions about unexplained phenomena and lying awake at night contemplating the stars. The same stars that shine over Area 51 shine over your own location tonight, wherever you may be, connecting you across the miles and the time zones to that quiet desert basin and to every other place on Earth, and to every human who has ever looked up at the night sky and felt the gentle pull of cosmic wonder. And those stars will continue shining long after this night has passed, long after this narration has ended, long after the questions of our particular era have given way to the questions of future generations, patient and steady, asking nothing, offering their ancient light as an invitation to keep wondering. Let the questions rest now. All the questions about classified aircraft and government secrecy and unexplained sightings and the long, strange history of that remote Nevada basin. Let them settle like dust after a long day's travel, not forgotten, but simply set aside for a time. And in their place, let there be only the quiet awareness of the stars overhead. The same stars that have witnessed every mystery and every explanation and every uncertainty that humans have ever known, shining with their steady ancient light, offering their wordless reassurance that mystery is not something to fear, but simply the natural condition of beings who are awake enough to notice how much remains unknown. And so you may drift now, gently and without resistance, into the soft darkness of sleep, carried by the slow rotation of the Earth beneath you, orbiting a modest yellow star, one of 200 billion stars in our galaxy, which is itself one of 2 trillion galaxies in the observable universe, all of it held together by gravity and time and the fundamental laws that govern everything from the smallest particles to the largest cosmic structures. And somewhere within all of this immensity, on one small planet, in one particular desert basin, questions were asked that remain partially unanswered. And this is not alarming, but simply interesting. Simply part of the long human conversation with the cosmos that has been ongoing since our ancestors first looked up at the night sky and wondered what they were seeing. The universe invites us to keep wondering, and that invitation remains open, patient, eternal, waiting for us whenever we are ready to resume our questions. But for now, in this quiet hour, the questions can wait, and there is only rest, only peace, only the gentle understanding that mystery is a gift rather than a burden. The universe's way of reminding us that there is always more to discover, always more to contemplate, always more to wonder about, beneath the same stars that shine over every question humanity has ever asked.